phosphorescence happens. Okay, and this is the characteristic curve representing this fluorescent spectra. Okay, see here. And next, so what are the methods by which you can measure the fluorescence? One is the direct method, where the natural fluorescence of the fluorescent sample is measured. Natural fluorescence is measured. Okay, இந்த மெத்தட் தான் வந்து அந்த வீடியோ ஃபைல்ல சொன்னது. டைரக்டா ஒரு சாம்பிள்ல ரேடியேஷன்ஸ் ஒரு ஸ்பெசிபிக் வேவ் லென்த் பாஸ் பண்ணி அந்த வேவ்ல அந்த சாம்பிள்ல இருந்து வர ஃப்ளூரசன்ஸை கேப்சர் பண்ணி பாஸ்பரசன்ஸ் ஃபில்டர் பண்ணிட்டு ஃப்ளூரசன் மட்டும் கேப்சர் பண்ணி டிடெக்டர் கிட்ட அனுப்புறது. ரைட்டா? தட் மெத்தட். ஸோ தட் இஸ் த டைரக்ட் மெத்தட். And you have certain indirect methods also, where the non-fluorescent compound is converted into fluorescent derivative by specific reaction or marked with the fluorescent dye by attaching dye to that substance, studied substance. Okay, this is the indirect methods. Next, there are certain materials which has this fluorescence property in a natural fluorophores, polyaromatic hydrocarbons, vitamin A, E, coenzymes, carotenes, quinines, steroids, aromatic amino acids, nucleotides. Okay, next fluorescent proteins. இதெல்லாம் இந்த what I'm trying to say is these compounds, the qualitative and the quantitative analysis of these compounds can be determined using the fluorometer. Okay, right. So இதுதான் உங்களுக்கு வந்து fluorometer they have explained. Right, fluorometer we have done it in the explanation also. Same you could see here at 90 degrees only they have placed the detector. 90 degrees they have placed the detector, and you could see one filter over here, one filter here, and this is another filter, where this particular the one filter, the primary filter is a wavelength selector to select a particular wavelength. Right, only on that particular wavelength only it will emit the fluorescent light. So that particular wavelength has been chosen, and that is made to hit on the sample. And another filter, this filter is to filter up the phosphorescence property of that sample. Right? So இதுதான் உங்களுக்கு வந்து fluorometer. Next, these are the sources. What are the sources? What sources can be used? Mercury arc lamp, xenon arc lamp, tungsten lamp. Mercury arc lamp na adoda features. This produce intense light spectrum above 350 nanometer. High pressure lamps give lines at these nanometers. Low pressure lamps give additional radiation at 254 nanometers. Similarly, xenon arc lamp. Intense radiation by passage of current through an atmosphere of xenon. அப்புறம் அதோட ஸ்பெக்ட்ரமோட ரேஞ்ச் 250 to 600 nanometers. Right. Next, a tungsten lamp. Intensity of this lamp is low and it does not offer UV radiation. So visible region மட்டும்தான் நம்ம tungsten lamp யூஸ் பண்ண முடியும். Next வந்து tunable dye lasers. So இதெல்லாம் various sources அதோட features explain பண்ணணும். Tunable dye lasers when the pulsed nitrogen laser is the primary source. Radiation in the range between 360 to 650 nanometer is produced. Okay. Next, what are the specific applications of fluorometer? So, இப்போ நீங்க படிக்கிற எல்லா ஸ்பெக்ட்ரோஃபோட்டோமீட்டருக்கும் specific what is its principle, construction சொல்லிட்டு next அதோட working சொல்லிட்டு next you have to next thing you have to look upon is the specific applications. என்னென்ன specific applications இருந்தா these applications you have to remember, students, and know that you have to study. Determination of inorganic substances. எந்தெந்த பாயிண்ட்ஸ் எல்லாம் தெரியுதோ ஒரு 4 அப்ளிகேஷன் எழுதினா கூட போதும். Qualitative and quantitative analysis of organic aromatic compounds present in cigarette smoke, air pollutants. Right? Next, the determination of vitamin B1 and B2. Field determination of uranium salts. determination of aluminum in alloys. So இதெல்லாம் எதுக்கு ஞாபகம் இருக்கும் படிச்சுக்கோங்க ரைட்டா இதான் fluorescence. There's a phosphorescence, it very clearly explained. This is nothing but a delayed emission of radiation. Sorry, delayed emission, that is phosphorescence. So this is simple. This diagram uh, represents the transition of electron from the singlet state, from the ground state to the singlet state. Okay. You could see here, then whatever it is being given, represented, whatever you have seen in that video, you have learned that video is being given here.